All right, we're taking a look at topic 2.4, example number 2. As we're looking at the constant of probability, looking at that equation k equals y divided by x. And so in example 2, we're taking the next step and learning how we can create equations based off of that by rearranging them. In the first example, you saw how mathematically you could rearrange it. So in example 2, they're jumping right into it. So we start with this idea. We're given a unit rate. 1 inch equals 2.54 centimeters. With that in mind then, the question is how many centimeters long is an 18-inch ruler? Write an equation to represent this relationship. So first of all, we have to understand what the relationship is. And so what is the y being divided by the x? And since we learned in unit rates that this 1 to, in this case, 2.4 ratio is what's going on, we would say that's what we're looking at. Right? On the y side, we would have centimeters. On the x side, you have inches. Right? So centimeters divided by inches equals k. Right? So how do we find k? Right? How do we find this constant multiple or the constant of proportionality? We're going to take y and we're going to divide by x. So we're going to take centimeters and we're going to divide by inches. And in this case, it's 2.54 divided by 1. So in the end, you come away with this equation. Y equals 2.54x. So because 2.54 is that constant of proportionality, we're able to just put that there, and now we can start plugging in whatever we want for x and y. If we know the inches, we can plug inches in. If we know the centimeters, we can plug centimeters in. Whatever the problem gives us. In this case, it says we have an 18-inch ruler. So next step. Next step says, all right, we've developed this equation here by finding the constant, right? We took y, which is this, divided by x, which was this part, and got 2.54 as k, our constant. Now, since we're trying to solve for how many centimeters this 18-inch ruler is, we're going to plug 18 in for x and multiply and get an answer of y equals 54.72. And in that case, we have solved our problem. All right, one for you to try. All right, taking a look at example 3 now. Example 3 has us looking at the fact that sometimes you see ratios, right? That comparison of one thing to another. But the question is, are they always proportional, right? And does this k equals y divided by x actually work as an equation for everything? So that's what example 3 is going to have you explore. Can you represent the total cost y for admission and x at the museum park using an equation in the form of y equals kx? Explain. So first thing we see is some information is given to us, right? A table that says, okay, if I do 1 ride, it costs me $25. I do 2 rides, it costs me $30. If I do 3 rides, it costs me $35. And so the first thing we want to do is plug this in and make sure that we can figure out kind of what the constant is on each of those lines, just to see if that constant is proportional. So to find that, right, we would take the cost, right, $25, put it over our x of 1. So 25 divided by 1 is, of course, 25. Then we're going to do the same thing with 30. 30 over 2. $30 over 2, now we have an answer of 15. And finally, we have 35 over 3, which gives us an answer of $11.67, approximately. And so as we look at that, right, proportional means is that you have a constant. That means that ratio is always the same. Even though the numbers are different, the ratio is always the same. So in other words, once you took your y and divided by x, you would always get the same answer. Now if we're looking here, we see we have a 25 for an answer, we have a 15 for an answer, and we have 11.67 for an answer. So they are not matching up. That means that this does not have a constant of proportionality. So there is no k that fits within this formula. There is no k. And so we would say that the relationship between one ride and two rides isn't proportional, just like the relationship between two rides and three rides isn't proportional. So we can't use this equation to be able to solve this problem. So the challenge here becomes, and we see this in the next example, is figuring out whether a table of information is proportional or not. And by looking at the table, by comparing your y to your x and figuring out what is the relationship between the y and the x for each row, if they match, it's constant. If they don't match, then it's going to be, then it's not going to be constant. That's what I meant to say. It's not going to be constant. And so we have that. And if you go back to example 1, you'll see a table that did that, where you saw the table, they compared the three rows, and when they were done, they showed how they got the same answer. It was that 0.8. Kept getting that, which showed that there was a constant. And so we would say that that is what allows it to have a constant probability. Not probability, proportionality. Whew, a lot of wonderfully big words for you guys to contemplate and think about. All right, this is lesson 2.4. Hopefully these explanations have helped you, and if they're not, or if you need a little more visual, just give me some feedback in class and I'll try and find some better ways to enhance these videos. I think I found a way I can finally write on them. We'll give them a try in the next lesson.